There we go.
You're going to Megazord your engines? All the custom features.
Well, we're going to keep on taking. We have 4 renders. 1 GitHub version. Yes. See if Hitler. Staff solution. We all get features. Jacob was trying to put together to work on an engine this summer.
Yeah.
Oh, really?
Kind of like put
Yeah,
together
we
the
have
parts of that.
Listen to this talk.
Sure.
Listen to this talk.
Next year.
It's going to be the next one. It's going to be the startup to take down Unity.
Oh yeah.
Knock it out.
All that time.
Okay, ladies and gentlemen, let's go ahead and get started. We are almost there. We have 1 lecture left. This is the penultimate lecture of Game Engine Architecture. On Monday, we will have a lecture from 4:30 to 6. It's one you're going to want to be at. We're going to have our final lecture. Those are usually pretty fun. And we're going to have some physical gifts to mark the completion of a very challenging course. I'm speaking to all of you watching this on Twitch. You are also going to want to be there if you are in my course. Yep, come get your stick. I mean, your reward, and yeah, that'll look really nice on your laptop. Okay, all right. So, what is there to talk about? You're in the middle of your final project features, your final kind of custom features. The grades, I think, are out for your milestones. A lot of them were very good, so long as you turned in your thing. And you should definitely continue working, even if you didn't turn in your thing. Because there's 100 points coming. And you put in a good effort here, you're going to get all 100 of those points. It's going to help your grades out a lot, okay? So hopefully that's fun for you. It sounds like everyone's having a pretty good time. Again, like the dream outcome for me, the way we drew it up was hopefully you'd get endeared to your engine, maybe a bit of Stockholm Syndrome during the auto-graded portion of the course, and then your custom features would really give you some fun ideas, things you can work on over the summer. At the very least, we hope this engine will be more than a throwaway GitHub repo for you. As you get new ideas, you can slap them into your engine. You can make them useful. You can use it on projects if you want to. And again, the whole thing, you look at people like Ravi and Nikhil who have crazy skill for their age, for their status as a student. Who's this like senior engineer going through my undergrad program? Who's this guy? And one of the reasons is that they spent a lot of time experimenting and working on these engines over the summer. In their spare time, they found satisfaction. They really started to enjoy it. And that is one of the best ways to a massive amount of knowledge, if you can get yourself hooked. Anyway, so we got a couple things that we're going to take care of today. And then Ravi has a phenomenal talk and workshop. We got a few slides. We also got some code we're going to show you on the topic of CMake. CMake, a phenomenal technology, very, very common in the industry, because the things you did with Visual Studio, Xcode, Make, right? Keeping all those 3 things maintained and synchronized as you're adding files, making changes, adding dependencies. No one likes that, pretty much. Okay, and so how do we get past that? We're going to show you how to do that today, all right? A very good thing to put on your resume and portfolio, by the way, CMake skills. I've got an engine for you first, though. Niantic Lightship, not necessarily an engine, but the last few lectures we've been talking a lot about how to think about engines. What is an engine? Can D&D be an engine? Can a card game? Can Bartok be an engine? The old 494 first lecture, where you have a really crappy card game, but you get to add a rule every time you play. And I think the answer is yes. Niantic Lightship is a framework. We're thinking about bringing it into EX440. It is technology that basically sits on top of Unity. The way you bring it into a project is via a Unity package plus a backend. If you go to the website for Niantic Lightship, you'll see that it has a sign-in page, which is always a little bit of a tip that this is not just a kind of client-only thing, a package thing. This technology is going to make use of Niantic's backend servers for things like multiplayer and stuff like that. And as a result, they need you to sign in, they need you to get an API code, and they're going to limit you, cap you, and they're eventually going to charge you, okay? That's how it goes with some of these things. If you come down here, you can see that Lightship is really pretty impressive AR technology. And I've heard, I haven't used it myself, I've heard what it gives you out of the box is significantly better and more consistent and stable than what you get with Unity Vanilla. Okay, AR Foundation is what Unity gives you by default. Lightship brings all the knowledge of Pokemon Go to your project, okay, or at least some of it. So you've got maps, kind of Pokemon Go style. You've got good detection for floors and surfaces, ground. This one's really cool. This is shared space AR, where your applications, your clients know where other clients are, other players are, and can visualize, for instance, projectiles that are being launched from those other clients. Yeah, that's a paid feature, okay? Very cool stuff. I noticed these are all iPhones, but I imagine this also works for Android. You can see that there are elements of occlusion here, which is a difficult challenge. How do you detect that something digital that you're trying to put onto the screen to augment the reality, how do you detect that it's actually further into the distance than some sort of wall or pillar or building, okay? And it's not easy, okay? A little bit of instability you saw there, but much better results than what Unity can provide, okay? This was created by the Pokemon Go company, which is Niantic, which was, I think, an offspin of Google. A bunch of Google game devs want to make a game. They got the Pokemon license because they first made their own IP called Ingress, which kind of did okay, helped them build out a lot of their database of landmarks and stuff like that. Then they used a lot of the same data for Pokemon Go, which is why it knew where all the landmarks and stuff were. Anyway, it is free for most use cases, and in typical fashion for this kind of thing, it gets expensive once you get big. All right, but even this doesn't sound that pricey. $5 you'll pay per 10,000 users per month. Okay, that could add up, but here's a question for you. Do you think if you've got 10,000 users, you could make at least $5 from those 10,000 users every month? And if the answer is not yes, you're in big trouble. As a company, and you should probably shrink and stop advertising and go back to being a hobby, okay? Anyway, one thing that's kind of interesting, if you look on this page, there's a data transfer cap of 50 megabytes, which isn't a lot, and that's the spookiest thing on this page. Forget the pricing. Okay, what is this MAU, monthly active user data transfer cap? 50 megabytes per monthly active user per month per app. It's a lot of pers in there, okay? And I think what they're indicating here, I'm not sure what data transfer means. If it means like you're synchronizing data to the cloud, they're basically saying don't do that. Or do that with like very small binary or textual data, like some basic save file stuff. If they're talking about like, oh, all the data that passes through our servers or passes between clients to like synchronize a multiplayer shared space game, that's like, that's not a whole lot of data for that kind of thing, okay? You got to be very efficient, all right? Get some flat buffers or Google protobufs going, like your life depends on it, or just pay them a bunch of money, okay? Why would Niantic make something like this? This is a very strange thing to see them do. Pokemon Go is a pretty impressive app. It works using a lot of their own proprietary custom technology. There are a lot of kind of tricky little problems that have to be solved in the world of global positioning. And yet they've done it, and they've given away their secret sauce, at least some of it. Why would they do this?
To help develop it.
To help develop it, okay, they want it to be more stable, more user-tested. But, I mean, they've already kind of done that through Pokemon, right? Tons of users testing it. That's a decent idea. It might be part of it.
They guess the money from Pokemon Go is drying up. They haven't really found a replacement for it.
The Pokemon Go money is drying up, and we need some other revenue stream. Okay? If you've taken 494 or 440, you probably got my business talk. At which point you know that's not about the product, it's all about what other P word, okay? It's not about the product, it's about the platform. okay? Platforms. Niantic just doesn't just want to create cool apps that use, AR and global positioning. They want to be the company that every other app like that sits on top of, so that they can apply a tax to the entire sector, the entire genre, the entire industry. Okay, that's the kind of thing that gets a investor excited. Maybe it works out, maybe it doesn't, but it gets the investor excited, and that's like the main objective. Okay, especially for new companies and startups, you have to keep your stakeholders excited, and they will keep throwing you cash. Okay. I just had one of my good friends, Andrew Yang. He runs Gaudium, the biggest mobile game studio in the state. They're now known as Parhelion, and that's a whole story. But he just got back from San Francisco from Anderson Horowitz. And people, you have to get very good at exciting investors if you want to get a bunch of capital to build out cool things. In fact, if you're good enough at this, you don't need a product, okay? If you're good at getting the right people very interested in what you're trying to do, you don't need a product. That's spooky to me too, okay? I'm not sure how much I like that. Anyway, so they've given away their secret sauce, perhaps because they really want it to at least make the attempt to make a platform. They might also say to themselves that our secret sauce is not our technology, it's probably our data. And they're not giving the data away, okay? Or at least not all of it. The landmarks, all that stuff. Anyway, I could be totally wrong here. But kind of an interesting little tool. It's also, I think, a little bit of a shot across Unity's bow. Okay, Unity provides AR Foundation. It's not very good. And so here comes Niantic kind of showing them how it's done, I suppose. It'd be really cool if Unity improved their stuff once in a while. That'd be pretty cool, I think. Yes?
Do you find that have you tested it? Have you found like object tracking to be a lot more consistent?
Nithisha has told me the answer is yes. Like much better.
Because I'm looking, I have an issue with that in the project I'm working on.
Okay.
I'm looking for alternatives.
Yeah, this would definitely be one to try. There are other ones out there as well, like Vuforia. Okay? But Unity AR Foundation is free, which is hard to beat sometimes. Okay, so a couple announcements before we begin with our talk on CMake. Your final lecture is going to come on Monday. Now, this is going to be kind of a weird timing because immediately after the lecture ends at 6, EECS 494 Showcase starts, okay? So if you're curious, you want to play some games, we got a really good batch of games this year. Trailers? Yeah. Promise me, the moment you start playing, you're going to believe, okay? Trailers are going to get better by Monday, I hope. Okay. And they're just drafts right now, okay? They're good for drafts. Anyway, please consider coming to lecture on Monday. We're going to get you some physical rewards that you'll probably enjoy. And we'll have a nice, fun talk about the topic of engines and their current kind of moment in history for engines, which is pretty poignant and important moment, in my opinion. Homework 10. Be sure to look at the assignment rubric on Canvas to kind of get a feel for how we're going to be grading. I think three criteria and then a penalty criteria if you turn stuff in late. So you're going to need to fill out a form, right, on the assignment spec. You're going to need to make progress. You're going to need to demonstrate that progress in a video, and you'll have to make it all happen on a portfolio website. You do that, you're golden. You're getting those 100 points, and you're out of here, okay? Unless you want to make a game with the engine in a week or two. But you can rest. That's going to be super chill, not stressful at all. So I hope you'll enjoy that. Any questions or anything? I'm not going to be having office hours on Monday, not logistically possible. And office hours for everyone is going to conclude after our final lecture, okay? You will have a postmortem essay to write. It's going to be very easy. You can take a lot of time to do it. It's mainly about you just reflecting on your development process, looking back and thinking about what you could have improved, very much in the style of 494 and 440, okay? Easy peasy. Get 50 points from that, I think. Very, very easy, okay? All right, any questions, comments? Okay, on Friday is the EECS 440. showcase. If you want to experience some cool XR, VR, AR apps, you can head into the Viz Studio. Hopefully, it will be much cooler in there by that point, and have a good time. I heard that's a really good course to take, actually. So if you haven't registered for it, that's definitely a winner. Okay. Anyway, all right. Let's go ahead and switch over to Ravi. Do you want to do some slides first?
Yeah, I'm going to do slides first.
Okay. So we'll do some slides first, and then we will get Ravi hooked up. Let me give you my clicker real quick. Here we go.
Just press the which button.
This is a little bit cooler. There you go. Left and right.
Okay.
Yep. Let's go. Here we go.
Cool. All right, today I'm going to talk about meta build systems, and we're not talking about Facebook here. We're talking about something that's a lot more useful. So when you're doing your projects, right, your cycle of development on your IDE projects will look something like this, right? We're kind of wrangling the three horsemen of the apocalypse, and each time you fix one, you break another one, and vice versa in a circle forever, right? This is kind of terrible, right? Nobody wants this. Every platform has its own weird way of doing every little thing, and you have to track all of them, you have to know all of them, and as soon as you don't know one, it's over, right? But if you look at all these panels, right, you probably realize that they're all kind of similar. Like, they're doing effectively the same thing, which is take your source code and turn it into an executable that can run on the device, right? So thinking about that, it's like, what if we had like a magic wizard that we could like give our source code and all of our settings to, and then the wizard would know about all the various platform idiosyncrasies that are required to compile for that target, but it just does that for you. Like, you don't have to do that yourself. You save so much time, right? And actually, such a wizard does exist. In fact, many of them do. And each of them target different things, all work in different ways. The one that I may be focusing on is CMake, because it's by far the most popular one. At this point, it's kind of become the industry standard. It's one of the oldest ones, too. And you'll see that like most C++ projects out there will at least have this one, if not the other. Some of the other ones, like the one in the bottom corner, is
Godot with sconce.
yeah, I forgot to put sconce on here, but I think Godot is the only one that uses sconce as far as I'm aware. Meson is like kind of the make replacement. I think it's probably easier to just kind of show you rather than tell, because I think it's a lot more compelling that way. But we need to switch to my computer to do that.
Okay. Let's go ahead and we'll bring this over to Ravi's computer. I'll leave the webcam on so you can still see the TV. And then we're going to do this. Okay. There you are. We.
Ready? Yes. I am connected. Oh, there we are. Cool.
Bingo.
Kind of rough for the Zoom for the Twitch people, but it's all right.
You'll be okay. They're not paying for it. Okay.
So right here we have like the most basic CMake project that you can have. You'll notice it's a lot simpler than what you have. We have our source file here and this txt here, and this is where all the magic happens. If you look inside, we'll see it defines what looks like a little programming language, right? Tell it what version you want, make the project, create an executable, and give it your source file. And so, but we can't use this, right? We need to have something we can compile. So what we're going to do is, so if you have Visual Studio, you actually already have CMake. It just kind of comes with it. So what we're going to do is we're going to jump into this folder with my shell. And then what I'm going to do type my first like magic incantation here, because we're telling the wizard what to do. It goes like this. We're going to tell it where our source code is, which is the current folder. We're going to tell it where we want to put the build artifacts, which is called build. And we're going to let it rip. And you'll see it starts immediately detects Visual Studio. It starts running and does a few things. And then we go in here and there's a Visual Studio project in here now. We can open it and give Visual Studio a second to figure it out. And see, it's done a few things here. So we can go into our project test. And so here it is. We're going to say I want to run this. So start a project. And like it's created like a bunch of debug and release things for us. x86 is the only target. But also there's some errors here. If I try to build this, it's not going to work, right? Because it doesn't know what string view is, no end is. And that's because we didn't tell it what version of C++ we're going to use. And actually, we don't need this anymore. Go here. And so we can actually, here's how we're kind of setting our first compiler setting here. We're going to tell it we want to use C++20 because that's when all this stuff was added. So then, of course, we need to tell it to update the project because we changed the rules. So we run this command again. Visual Studio detects that it has been changed. And then we look, and now see the errors are gone. It's able to syntax highlight now. If I run this, you see that it says your computer is little endian, which it is because it's x64. So like just like that, we have a Visual Studio project. But it's like, well, that's not that interesting because like I just have these two things, right? Like a real code base is a lot more involved than that. And this is kind of the real power of meta-build systems like CMake is that you can chain these together. So what I'm going to do is we're going to go into my second thing. So out of 10, how would you all rate your experience trying to build SDL? 10? 10?
Well, with since the tutorial is the only way I
Yeah, but wouldn't it be cool if you didn't have to do that, right? So what I'm going to do is I'm going to run that same command again, but this time in the SDL folder. And I already ran some of it because it takes a while to run. But notice that now we have a bunch of SDL stuff that's just been dumped out into our console here. And if we look inside of the CMake file, actually I'll do that. I'll open the project first. So we have another Visual Studio project. It's kind of sitting in here. And you see it starts loading some SDL stuff down here. If you look, SDL3 shared is, why is this a DLP project? Wait, that's weird. Okay, never mind. I need to have it do the right thing this time. So that's the other thing is that you can build for many different platforms. Windows is not just the only one. So hopefully this doesn't take forever. But while it's doing that, let's look at this file. And you'll see that it looks very similar to the other one. We have a couple of extra things up here, which I'll talk about in a minute. But we do the kind of same thing again. We create an executable. We tell it to C++20. We set a define, in this case, a global define. Then we have these two things here. So one called add subdirectory, and this next one that says target link libraries. So it's pointing at the SDL folder. So let's go look in the SDL folder. And in here is actually just like I download the source code off GitHub, and it's just in here. And SDL actually has one of these, and so we can look at what theirs looks like, and you'll see that there's actually quite a bit going on in here. But we don't actually have to worry about that. All you have to know is that they call add library, and you can see like there's one, there's another one, and that becomes everything that they did in that file becomes available to us up here. And so once we have that, we now have a library called SDL, it's namespace, and we can link to it. This is still not done, so I'll explain what this is. So in the previous example, we just had that one source file, and that was it. But sometimes you might have things like DLLs or other resources that your program needs to load. And if you remember from dealing from Windows, where those end up is important, and if they're not in the right spot, it won't run. And so you remember setting up that custom file copy command in Visual Studio to put the DLL in the right spot. Because we're compiling this from source, we can actually just tell CMake when it creates DLLs where to put them. And so by setting these, we can actually tell we want to place them next to our executable, which is what this is right here. Binary dir is where I ran this command from. And then configuration is like debug versus release versus min size rel, etc. Look, it's done. Just right on time. Let's go in here and open it up and take a look. So it doesn't say Universal Windows anymore, which is good. So this is a startup project. Take a look inside, and we'll see this should look pretty familiar. Now, it's not quite the same because this is SDL3, and they added a new event-based API, which is better. But a lot of this stuff is similar. Like, you create a render, create a window, show the window, do some stuff. So I'm just going to hit build, and it's going to start doing a bunch of stuff. Notice a bunch of SDL sources down here. Because what it's doing is actually it's compiling the SDL code base itself from source, and then once it's done doing that, it will compile our source file. And it's not really using my computer to do that, though. Oh, there we go. It's done. And Zach. Okay, that's kind of weird, but you notice that it created a window, and I don't know what happened after that. Okay, it's just
So now
SDL3 is kind of buggy. Don't use it yet.
So
this worked yesterday.
You know how Visual Studio Xcode and Makefile need things, so you should go fix this up on the repo, okay?
I reported a bug to SDL a couple days ago. So if you look inside, you'll notice that there's a debug folder here, and look, there's the DLL, just kind of right there, just hanging out. Okay, it's working now. That's fine. So I can resize this, I can drag it around, it printed out some stuff. But all I had to do was just have these two files here, and then a copy of the SDL source code. That's it. You're done. You don't have to do anything else. And crucially, actually, because we're building it from source code, we have all the debug symbols for SDL. So, which is important because what it means is that if there's some kind of problem in SDL, for example, I want to see what create window is actually doing. I can set a breakpoint right here and then run it. Let's go step into, and it's going to do that. But look at that. We're inside of SDL create window, and we can take a look at it. We can look at everything it's doing, and we can pop back out if we're satisfied with it. If we crash it on purpose, you'll see an actual stack trace. And that helps a lot because it means that you can actually interrogate what's actually happening. You don't have this opaque binary that just does mysterious things whenever you call functions into it. And if there's any kind of problem, like there's a bug in SDL and you need it fixed right now, you can just change it and it will just happen. But of course, I've been running on Windows this whole time, but you may want to do more than just generate Visual Studio projects. And so for that, I'm going to restart my computer.
Okay. So this is really cool technology and stuff, but I'm guessing all of you still prefer the Visual Studio, then Xcode, then Makefile manual method, right? Right?
Well, it gets better.
What? It's better.
It gets better. Visual Studio products are fine, right? What if you wanted to ship on more than just Windows, or a console or something that doesn't have an easy IDE project that you can just run? It'll come back in a second.
Will it?
Well, I have to.
Oh.
It's not putting video yet because I haven't logged in. Okay, yeah. I said managed to set up a VM, so I have to restart my computer, but we'll learn, I guess.
Are you just dual booting?
Yeah, I'm dual booting it. And part of the reason for that is because that way GPUs actually work. If you've ever tried to pass through a GPU in a VM, it's painful and often doesn't work.
Did anyone in the class use CMake? I think a
Some
couple
people did. I saw some.
I did at the beginning,
yeah.
but it wasn't. It wouldn't work on the auto creator.
Yes.
I just can't deal with my phone.
Yeah.
Yeah.
So now we're over here on Mac OS now, and everyone had a lot of fun with Xcode projects, right? So what we're going to do is we're going to. I have CMake on here now. You have to install this if you're on. It doesn't come with Xcode, but I'm going to do the same thing. Might be a little small, but that's fine. Build, and what we're going to do is we have. I'm going to go back in here. It's the same file, right? And actually, because I already showed you about the endian in this thing, we can just go ahead and fix that. And I'm just going to run this again. And this time, actually, hold on, I forgot one thing. For that. We're going to change the generator to Xcode. Because by default, it says, oh, you're a Unix system, right? You want to make file, don't you? In this case, we don't. But there's many different kinds of generator. And actually, you can tell it which one you want through this flag. So this time,
Can you make an Xcode project even when you're on Windows?
No, unfortunately. I mean, theoretically they could, but I think they interrogate the Apple SDKs
Sure.
to figure out what's available.
Yep.
And you can't do that on Windows. So for the reasons, this likes to say, okay, there we go. Now it's here, but this time the compiler is Apple playing. And if you look inside here, yep, there's an hello CMake to the Xcode projects. Let's open it up and take a look. This computer is old, so it takes a while to do anything. Yeah.
So even though like if you're on Windows, you can't make the Xcode project.
Mhm.
You can like you basically don't have to worry about like having to change settings for Xcode.
Yeah, so the workflow is different. So you're not checking these projects into your Git history. And actually, these build folders are supposed to be like machine local, and they're hard coding paths to generate these. And so your git ignores actually get really simple. If you look at this git ignore, no, of course not. Let's look at my git ignore. You'll see that it just ignores build folders and dstore files. That's it. Everything goes in the build folder, so you don't have to worry about ignoring every single little file that like Visual Studio makes, because they all go in the same spot. So if I open this up, we'll see we have our test right here. And I set to C++20 already, so we run this. It built it, and your computer is a little endian. And like I just got this project for free. I didn't have to do anything. I just took the literal exact thing and just changed the command I ran. But you can actually do more than just this. So what if I wanted to make something built from a more like exotic target, right? So I'm gonna go into the SDL demo, which is the same. I pre-ran because I'm on Xcode. This takes forever, like 10 minutes, so I'm not gonna run it again. So you can watch it slowly scroll past. But to still fit the point, this is the Xcode project that it made. It's the exact same code. I'm just gonna hit run on it, and it's gonna build. It's going to eventually launch our targets. Oh, there it is. I can resize it, move it around, quit. Eventually, yes. So, what if I want to do like, yeah.
I don't know if I missed this or not, but how did you get the embedded design or whatever for the frameworks of SDL?
There is no framework.
Okay, got
it. Just compile it. We can actually look inside of this SDL folder, debug. Like there they are right here. These got compiled automatically.
Is that partially because you compiled all of the SDL source files and then there is no like dot framework? Or
yeah, you can tell CMake to generate the dot framework for macOS if you want.
Okay.
But why would you do that?
Right.
You don't have to. The headers. The only reason why you want a framework is because they can have the headers inside of it. But you already have the headers. You have the source code, so there's no reason to do that.
Gotcha.
So what I'm going to do now is I'm going to, I want to run, not just the desktop build, I want to run this on my browser. So if you think about this, like if you're trying to make an Xcode project or a Visual Studio project, like how would you even do that? Like mystery, right? Well, web builds kind of run on CMake, and there's a good reason for that. So I have a copy of Inscripted here. What? And Inscripted is it's kind of interesting project. It's a Clang fork that can output WebAssembly. And what they've done is they basically implemented all the like POSIX calls for a browser, which is kind of crazy. And they just make it work somehow. So I have to set up some environment variables to do this. So I'm going to source SDK. No, not that one. And what this is going to do is it's going to add some files to my path. These are not super important, but what it's done here is it has added this cmake command, which what it's going to do is it's going to allow us to use CMake to generate web build. So we're going to go back. I'm going to go back in here, and we're going to do cmake. CMake, because we have to call CMake. We're going to say this is our source folder again. we're gonna set the build folder to web build, and I've already ran this once because again it takes forever. But this is gonna refresh it. But as soon as what it did was it added this thing called CMake toolchain file, and this is kind of the magic sauce here because obviously the Apple tools don't know about web builds at all. But what you can do is you can tell CMake about custom compilers, and that allows it to generate a make file in this case that can generate web builds. So what we'll then do is I'll use we'll shell build this time because we don't have an IDE project. If you look inside here, there's a make file and it's got stuff in it. So we'll do CMake -- build this target STL, what I call it, test, and hit enter. Oh yeah, this is parallel, so it doesn't take forever. And, oh yeah, it's web build. These are targets. Let's see, it starts building some stuff, and you look in here. It generated this thing called STL test.html, and there it is.
What does the parallel flag do?
It tells it to multi-core build.
Okay, gotcha.
Because by default, some make doesn't. So you have to tell it to. So that kind of forces it to always do it. And notice that even though I'm doing a make file, I didn't tell. There's no sign of make in here at all. And that's one of the nice things is that it doesn't matter what generator you use, whether it's make or Ninja or Xcode, that command always works to build a target. So if you're trying to automate something on a CI system, you can very easily automate builds for any generator. So I can just run this right away because it needs a server. So I'll do Python 3-m server. And then we're going to open up my browser. And we're going to go to, I don't know why it's so slow today. We're going to go to localhost 8000. And we have our web build. And then we have our HTML file there. Let's go to it. And there it is, running in the browser, just
Good
like
job,
that.
Robbie. Well done.
So yeah, that again, I didn't have to do anything, specific. Actually, I had to do one thing, and that is important. So there's this one extra thing. So even though these things are cross-platform, you still have to have some, target-specific stuff in here. In this case, we have to tell CMake that we actually want an HTML file. Oh, it's just going to generate the WASM, and that's not very helpful. So in this case, if we're targeting mscripten, then make HTML files. If you're on any other platform, then this gets skipped, and you don't have to worry about it.
I know this is a silly question, but how is STL working in browser? Because I always thought it was only
So the reason why
There's
STL works in a browser is because the STL team made it work in a browser. They have all the necessary stuff in place to make sure that this works. And so now these look pretty simple, but these CMake files can get pretty involved. I'll show you what mine looks like, because just as you add more and more stuff, as you get more involved, these things can get kind of crazy. So let's keeps going. But if you look at that's just because there's a lot of platform-specific stuff that's in here. But unlike the manual projects, it's just all here. I can look at all of it at once. I don't have to go diving through 4 or 5 different build systems to see it all. And if you look inside, it's doing the same hierarchical thing that we're doing with STL. All dependencies I use are just in this folder. You go inside one of them, and there's a CMake file here. If I go inside this one, there's another one. It's just this ability to chain them together is what makes these so powerful. And you can often visit, for example, if I go to Popular rendering library, you'll see that this is just a library, and there it is. That's their way of integrating it. And CMake is a Turing complete language. It's kind of that way by accident. So, and it shows in the syntax, but it's become the industry standard at this point. It's the fact that it's a TXT kind of tells how old it is. Yeah.
So, I guess the caveat is that if you're adding a library, it has to have that CMake this.txt.
So, if you're doing it the way that I prefer to do it, which is compile everything from source and have a checkout of the code in your tree, then yeah, it does have to be that way. However, there are CMake has the ability to include non-CMake projects. There's a few of them. One of them is fetch content, which I think if you have it, it's instead of having to have a copy of it in your tree, you can tell CMake when it's compiling to just go download it for you. You can get a git checkout and a version, and it will then figure out what to do. There's also external native build, and that's what you would use if you're trying to use a project that uses like make or something old, is you can tell CMake the commands it needs to run in order to build that project, and then where the libraries are outputted to and all the headers are, and then it can figure out how to link those together. It's not as seamless, but it does work. Yeah.
So, since you're like compiling SDL with CMake, do you have to do that every time? Like you make a change to your project, or will CMake kind of smartly know, okay, this file has not changed. I'm not going to redo that.
Yeah.
I'm only going to redo the files you changed.
So it's incremental.
It is.
So I have like my total repo size. We count every single source file is like 13,000 files, and that would take a long time to recompile the whole thing. But it's smart enough to set the project such that, including make files, such that if you change one file, it just rebuilds the one file and then does whatever linking it needs to do to get it all the way up to the top. Which is, beats handwriting make files. Like your make files in this class would rebuild everything every single time, and that was really slow, right?
So this is just odd. This doesn't really even concern CMake at all, but I noticed when I make just changes in header files, make doesn't detect sometimes it doesn't detect those changes. So I have to go to the source file, enter, erase, make.
Yeah, so CMake does not, as far as I know, does not understand those dependencies.
Gotcha.
But IDE projects do.
Okay.
And so if you include, like when CMake generates a Visual Studio project, Visual Studio itself is smart enough to go and internally track all that stuff.
Okay.
If you have a generated make file, I don't know what CMake does in that case. I think they may just, if you declare headers and they know about them, and then they'll go, oh, change, we'll rebuild the library. But I don't think CMake itself goes and parses your source and figures out what the actual tree is.
That's the only thing I would have, like when I just did with make files. So
I think Ninja might, but I haven't rigorously tested it.
So you remember when we were talking about SDL, it's middleware. And so we all need to pour one out for the SDL developers who have to learn all the different kind of native operating system APIs so that we don't have to. We can stand upon their shoulders. Okay, you should pour one out again for the CMake developers who need to know all of these build systems inside out so that they can have their meta build system work to protect us.
One of my favorite CMake trivia is that if you go to their sponsors, which they moved it, so I don't know. Oh yeah, you'll see National Library of Medicine is on here. So national. These are all wow. Government.
Oh goodness.
Yeah. So your tax dollars at work are making this. Yeah.
Silly question. Is CMake open source?
It is actually. It's on GitLab. They have their own little GitLab instance. There it is. And in classic fashion, you compile CMake with CMake. They have a CMake file.
Do they also have options for other?
Well, that's not. Well, that's a Rust compiler built on Rust.
No, you
just have to
CMake.
You download CMake and build it. Yeah, so you have to they bootstrap. So you have to have an older version of CMake.
What was the first version of CMake?
Well, consider this a TXT. It was probably just a list of files in a bash script that compiled it.
Yeah.
Because it has to be named CMake-list.txt. It has to be capitalized this way. It has to be .txt. That shows you how old it is. It probably was literally just a list of paths in a file at one point and just outgrew that over time. Also, there's the ray tracer written in CMake language.
Oh no.
Yeah, because it's Turing complete, so you can do anything with it, including math. So yeah, hold on. Do we have? Oh yeah. So let's go back to this because there's
there's a
couple
more
links.
Okay, we'll go back.
Yeah. That's what it is.
Okay.
Yeah, because
Bloop.
it build Rust, and you see the Rust compile is 99% Rust, but 1%
Well, like Clang and GCC are both written in C++, so
yeah.
there needed to be a C compiler at some point to make that.
Okay.
Just compile it.
Right. So this is one more slide. So the code I use for these demos is available here, and then also I wrote some tutorial for CMake, which I actually I use my own tutorial to go visit it. Like because this explains how to set up everything because I don't remember how to do it, and so here you go. It's not a video, so you can actually search it, and it just explains how to do everything. How to set your compiler version, how to add a library, how to add an executable,
All right. Questions? Any more questions?
How long did it take you to learn like CMake?
So when I was playing Mansion originally, I was doing what you were doing, which was have a manual project, and just at some point it became untenable. And so I was looking at someone recommended like you should use CMake because whatever I was using, and I slowly figured out how to use it. It took a while though, because before this, like as far as I'm aware, this is the best CMake tutorial, and I'm not just tooting my own horn. Like I wrote this because of how bad most of the information out there is about how to use CMake. Like CMake has documentation, but it's documentation that seems to assume you already know how to use it.
Yeah.
It's bizarre. And like old, there's like a old C++ and like the current meta. That's true of CMake as well. There's like old crusty CMake that you should never do now, and there's like modern CMake. And a lot of tutorials use the old stupid way, and in fact, some code still does it that way, and that can cause problems. But so I have this now, and I just point people at my tutorial now because it actually tells you what you need to know. Yeah.
So we have build systems, Make, Visual Studio, Xcode, but no one wants to deal with those. So we have the meta build system like CMake, AutoConf, Scans. So what I'm wondering is there a meta build system so we don't have to worry about CMake or Scans?
No, actually, there is.
Oh my god! Oh, that was a joke.
People tend to people do some really interesting things. Let's
Physics.
go. Yes. So the way PhysX, you can't tell from this, but they use CMake to build their stuff. However, their build instructions, wherever they put those, have you invoking a Python script. And this Python script is just calling CMake, reading an XML file. I don't know why they did that. Like they're combining CMake with a custom build system, and of course there's no documentation on what flags they're passing, so you have to like reverse engineer their Python script in order to get it to build.
The library I'm using for graphics uses CMake to call a Python script.
That's worse. I've seen like Chronos Tools does that. And you'll see a lot of like CMake things look for Python because they're trying to do like code gen and stuff.
Yeah.
It's like stop doing that.
So Python is the meta build system.
Well,
There you go.
If you have Python generating CMake calling Python to call CMake is horrible. Yeah.
I think this gets to another interesting point. UX is a big deal these days in a lot of sectors. I feel like it gets ignored in the developer kind of space. This is to say that in the same way that you just spent some time, many of you, thinking about not only how do I create this new feature, but what's the easiest way for my users to use it? Like that's kind of at the heart of a game engine. You build a game engine, but no one needs a game engine to make a game. They could go learn everything from scratch, but the whole point of the game engine is to create a really good kind of abstracted user experience. And so when you're making things, we talk about this in 494, you might be making a function. Think about how you're going to name that. Think about what parameters you will have, not too many, but not too few. You want to achieve a good balance of expressiveness with a good user experience. Because every time someone messes that function up or uses it incorrectly, they get blown up. They're going to call you. You lose time. Okay? Hardiness, right? So when you're developing something, think of your poor developers, your colleagues, okay? Make it as easy for them to use as pie, and they'll love it. They'll use it, okay? They might even tell their friends to use it. And that's how a game engine starts to grow.
A little bit on the UI spec. So at my job, we had to do we released open source software, and holy hell, we had incoming things of like, why is it built like this? This doesn't work right. And the way we thought about it was super intuitive, but to like that.
Yeah.
It was a very niche software, but like, but the people who used it didn't understand like certain caveats that we thought that would be important. So even with that, and then building this UI, I'm like, I know what the hell this does. No one else is going to know what this does.
You know, we talked about Godot on Monday, and I also talked a little bit about how Godot they had their chance, the big chance to scoop a ton of Unity's market share, and they kind of fumbled the bag a bit. And it was always going to be hard, but one of the reasons they fumbled the bag is like, I've seen a lot of people try and make that transition from Unity. They're very used to it. Components, yeah, okay. Oh, Godot has C#. This is going to be easy. And they just bounce right off Godot. Like, oh, I can only attach one script to my nodes? That's weird. Why can't I have as many as I want? Then they're like components, right? Godot, their documentation kind of makes it a bit hard to transition from Unity. And you might have seen, in order to move my camera, move my objects during the demo, it was a fast demo, but you can't just do like position equals or transform.position equals. Do you recall what we had to type? What was it?
It started with a T, didn't it?
Yeah.
I don't remember.
Think about your matrix, your transform matrix, but that's not what we wrote. Translation is what we wrote. Translation is an intuitive term if you are in that 3D graphics mindset, which the developers might have been. But very few people, gameplay programmers, are in that mindset. They're like, I just want to change the location or position. And so people bounce off that stuff. That's Godot 3. If you use the latest Godot 4, guess what it's called now?
Or still translate.
It's position. Right. They got the memo. This is bad. We got to fix this, okay? And again, in the same way that you can learn whatever you want to just by observing about game design. You can learn any game design you want to just by observing close enough and doing enough tests with enough people. Like, you can learn so much just by careful observation when it comes to UX, UI, and DX, that developer experience too. So, all right, Ravi, thank you so much again for this lecture. Fantastic. I could feel a little bit of rage bubbling. Okay, Austin, why did you put us through this? CMake is so nice and wonderful. But I do think there's still some value to navigating the UI and getting a feel for, okay, this is a pain. This is why CMake is so special and why people love it. In the next semester, we're going to have more videos to get kind of clean up the friction, at least get you opening that SDL window quickly on each platform. So that's going to take away a lot of the pain, I think. Anyone have any questions or comments on any topic or about the course in general before we wrap up? Yes?
I just want to say, if we had gone right into CMake, I would have had no clue how to debug anything on Xcode.
Yeah, CMake hides a lot of stuff from you, and that's not always the best when you're learning.
But if you want to just change some flag, you look online and it says change this flag in the Xcode build settings. But then you have to figure out how to tell CMake to tell Xcode to change that flag. And that's
Yeah. Anyone else? All right, everyone. We've got until 8 o'clock office hours. If you want to talk with me about anything, if you want help getting something to compile or just want to run your ideas for this week past us, I'll be here until 8. Maybe Ravi will hang around for a tiny bit if you want to talk CMake with him. We might relocate into that super warm room, but I'm feeling all right out here. Not too bad out here. Yeah, it is hot, but in there.
It's really, oh my gosh. It's like a song in the other.
Yes.
I was having technically started, so we could stay. This is still lecture.
Yeah, you're right. This is lecture. This doesn't feel like lecture. All right, everyone. Thank you so much for joining us online. I hope the image wasn't too bad through the webcam. The joke I make only applies to YouTubers watching. I do feel bad for the students watching. Let us know if you have any questions on the course or on the CMake. send me a DM, send me an email, or ask on Piazza, and we'll try and get you an answer. Okay. Have a chillaxed week. Not a super hard assignment you're doing, and we'll see you. We'll see you on Monday. Okay. Bye bye.